In this video, we'll compare ZeroMQ and Aeron in their native environments, ingesting and distributing market data. In trading, latency plays a huge role and can be a deciding factor in whether you make or lose money. So we'll measure latency, throughput, and saturation. In the second test, we'll use IPC protocol and replicate the same setup to give you an idea of how much performance can improve by placing all components on a single server. In trading, speed is very important. If you can collocate your application near exchange and receive L2 and L3 data, you would ingest that market data and send it over to the in-memory order book application responsible for building and constantly updating that order book. If you just receive L1 data, which is top of the book, you ingest only best bid and offer prices with trades. In that case, you might distribute the data across strategies, OMS, executor, and other parts of the system. If you have all those components on different servers, you would mostly use UDP multicasting to reduce latency. Here we have a very popular Aeron framework that does exactly this. It can use UDP unicast, which is one-to-one relationship, multicast one-to-many, and other protocols. Most importantly, they have a layer on top of UDP to verify that none of the messages are lost and all delivered to the client. On the other hand, we have ZeroMQ, which is originally created specifically for market data handling. There are a lot of protocols available, but they don't have reliable UDP. Instead, you can use PJM protocol for reliable multicasting. It's similar to what Aeron does with UDP. Now, if you can fit all your components into a single server, you will get much higher speed and lower latency with the IPC protocol, which you will see in the second test. That way, you don't have the overhead of TCP/IP stack, and it really improves latency and throughput. Now, for simplicity, I'll use in the first test Aeron UDP unicast, and ZeroMQ pops up with TCP protocol, which is also one-to-one relationship. Keep in mind, both Aeron with UDP and ZeroMQ with TCP verify delivery of the message, so it's fair to compare. And in the second test, it's just IPC protocol for both. And I'll use C++ programming language, and you can find the source code in my public GitHub repository. ZeroMQ is much simpler to set up. You just have a publisher and a subscriber on different servers. For Aeron, when using C++, you need to compile and run Aeron-D daemon on each server, so the requests go through that component between applications. It's like a service mesh. And well, SB, Simple Binary Encoding, is a protocol for decoding and encoding messages, which is very common in trading because it's very efficient to decode and very small. For example, Binance provides market data via WebSocket using the same SB format. I run all my tests on AWS to give you a real-world performance that you can get in production. I use M7A large instances for producers and consumers, as well as EKS for monitoring. Alright, let's go ahead and run the test. I'll slowly increase the number of requests until both applications fail to process anymore. From the very start, you can notice that Aeron subscriber uses 50% of the CPU. Since I use two CPUs, it actually consumes all CPU from a single thread. It's actually intentional. It's called a busy strategy that runs, and you usually use it when you need the lowest latency possible. ZeroMQ, on the other hand, will slowly increase the CPU usage throughout the test. Well, you can see that ZeroMQ with a regular TCP actually performs better. In trading, latency is most important metric because you compete with other people and algos. And if you have higher latency, that means you would get a higher percentage of slippage and might lose money. Aeron has a paid version with a kernel bypass, which is actually faster, but I use open source version that any of you can use as well. With open source, ZeroMQ actually performs better. I also measure network usage. Each message encoded in SBE is 70 bytes, but for some reason Aeron subscriber has a higher usage, maybe due to abstraction layer on top of UDP to confirm delivery. You can also notice higher memory usage for Aeron. It's mostly because you need to run both application and Aeron-D media driver on each server. Moving forward, you might also notice that with higher volume it will reduce latency a little bit. Alright, let me run the test for 1 more minute and we'll go over each graph one by one. First, we have latency. With Aeron, when you have enough volume, the latency will be lower. You can see a spike by the end of the test, because I completely remove the delay and each publisher produces as many messages as it can. Next, we have throughput, which is similar for both. Take note of this number, which is around 900,000 messages per second that can be delivered from one server to another. Compared to REST API and previous benchmark, it's a huge number. It would actually be interesting to compare Aeron with WebSockets. Next, we have CPU usage. Memory usage. And finally, network usage. So ZeroMQ actually performed better than Aeron, and it's much easier to set up and maintain. It's just a library that you use in your application. That's something to keep in mind. So the latency was around 80 microseconds. Let's go ahead and run the second test. I just want to clarify that there are no source code changes for the second test. I only use environment variable to set the channel for ZeroMQ and Aeron, so it's identical to the first test. But in this test, we place subscriber and publisher on the same server. For ZeroMQ, you can see that latency fell from 80 microseconds down to 40, which is a nice improvement. But every microsecond counts in HFT trading. But for Aeron, it now actually fell down to nanoseconds, which is a huge improvement with no source code changes. 1 microsecond is 1000 nanoseconds, and this is where Aeron shines. I also use exactly the same busy strategy to keep loop running. Alright, let me run this test for 1 more minute. For ZeroMQ, it's still around 900,000 messages per second, but for Aeron, it's up to 20 million messages per second. Well, you can argue that if you use Q based on ring buffer and shared memory, you perhaps can even double the throughput and reduce latency even more. But this would require you to build a monolith. This approach works great if you have standalone applications running on the same server. First, we have latency, throughput, CPU usage, memory usage, and finally network usage. Well, as you can see, latency really matters in trading. And if you can achieve lower latency than others, you have edge in trading and can make more money. There are FPGA cards as well, which I might cover in the future.